Bam! Mr. Tarrou. In this video and the next two, we are going to be introduced to the law of sine, the law of cosine, and the ambiguous case for law of sine. I'm going to revisit a topic I taught years and years and years ago on YouTube and in my classroom. You'll find a link to those old lessons in the description if you want some more examples, but hopefully with all the years of experience, this one will be better. You'll also find links to applications of law in cosine, such as questions dealing with bearing or navigation and such, also in the description. So first things first. Instead of introducing the law of sine and law of cosine to you separately, and we're going to do law of sine today, not the ambiguous case. I first want to talk about the difference. When do you know which, to apply which rule? So here we have part A, which we're going to be solving in a few minutes. This oblique triangle, non-right triangle, that has an angle of 48, 37 degrees, and finally another side, which is 100 units of some measure, or some unit of measure. We have in part B, the statement here that we have angle A is 65 degrees, angle B is also 65 degrees, so we're looking at an isosceles triangle, and side C is 3 units long. Now B does not offer us a diagram, so let's make one. You never really want to do a geometry problem without a picture. Now, it doesn't really matter how you make this look. I see that I have two angles that are equal, so I'll make something that looks isosceles, but really I just want a diagram to allow me to put down some numbers. So we have angle A is 65. Don't worry about trying to make it to scale usually. It's not very helpful. B is equal to also 65 degrees, which of course means that side A and side B, when we find them, are going to be the same measurement. And then side C is equal to 3 units. I know this is a side because this is lowercase, where up here we're using uppercase letters. And we don't know what angle C is. Not very hard to find, but at this moment it's not given. Okay. Over here, trying to pause to see what I want to say first, we have another given triangle. This time, and as opposed to these two problems, we are not given any angle measure, so that might need a different technique to solve. And here we have another problem that does not give us the diagram of a triangle. So I'm just going to draw something, not really thinking about necessarily the shape, just give me something to put some stuff down. I'll go ahead and put angle B up here. And angle C. Well, side B is 4. The side measurements are opposite the angle measurements, so maybe we don't know what the measure of angle B is, but we know that the side opposite to it is equal to 4 units. Angle C is 96 degrees, so it's obtuse, but it doesn't look like it in the picture. No big deal. And side A is equal to 6. Now, 2 of these questions are going to require us to use law of sine, and 2 of these questions are going to require the law of cosine. So let's write out the formulas and see if we can figure out when to use which law. So let's see here. The law of cosine, there's 3 versions, but basically a side squared is equal to the other 2 sides squared and added together, and then minus 2 times those other 2 sides times the cosine of the angle that's opposite the given side. And then we have law of sine, which has 2 equal signs, but we don't work with necessarily, we're not going to work with all 3 parts of this equation. We're just going to work with 2, an equation with 1 equal sign. But we have and books will vary this because you can have it flipped or not, but it'll be side B over the sine of B, except I don't know why I'm starting with B, it should be A. So A over the sine of A is equal to B over the sine of B, and equal to C over the sine of C, or your textbook may have the sine functions on top. No difference. Just looks funny, at least to me. Okay. To do law of sine, thinking with the fact that you're going to be working, say, with just 2 parts of this as an equation, to work with this, you need to have information about a side and the angle that is opposite that side. Which means that here with triangle A, we do have an angle and a side opposite that angle, which means that this is a law of sine problem. Here, while we seem to be, and I never wrote it, since we're told that c is equal to 3, it doesn't appear that necessarily we know a side and the angle opposite to that side, but we do because, I mean, how many degrees are inside of a triangle? 180 degrees. So 65 and 65 makes what, 130 degrees? Take that out of 180 and you've got a 50-degree angle. Hey, one part of this triangle is already solved and we know an angle and the side opposite. So this is also going to be solved with law of sine. So our video is going to consist of us solving for these two triangles. Over here, I said it was 2 and 2, so I kind of gave it away. We have all three sides given. There's no way, at least, well, there is a way, where the whole point of this is to solve these triangles, but we're not given information about a side and the angle opposite to it. So because of this, we're going to be doing law of sine. And here, same thing. We have two sides and an included angle. Well, we don't have a quick way, like over here, finding angle C. We have no sort of easy, per se, way of finding side C, so we're not going to be able to initially have the option of doing any work with law of sine. This is also going to be a law of cosine problem. Oh, I said law of cosine, I wrote law of sine. Write what I say, I hope. Okay, so now you understand how to determine whether you use law of sine or law of cosine. If you know a side and a given angle, or if it's super duper easy to find, a side and an opposite angle, you're going to approach that with law of sine. If you are given three sides or two sides and an included angle, that's law of cosine. Now, we haven't got to the math yet, but it's important to just see all this as a big picture, I believe, with my years of experience. Now you know how to determine whether you use a law of sine or cosine, and all four of these are going to have something really, really nice in common. Do you remember, because all the stuff that we learn keeps coming back, right? Do you remember your congruency theorems from geometry, how to prove when two triangles are congruent? You could argue that it still works for similarity too, but your congruency theorems, two triangles are congruent if you can prove that each of the corresponding sides are equal in length. You can prove that two triangles are congruent if you can use the side angle side theorem, the angle side angle theorem, and the angle angle side. Now I know we're not comparing two triangles, but there's something sticky that you have to worry about when you are solving not oblique triangles with law of sine and cosine, especially specifically law of sine. Here we have a side, side, side. That side, side, side pattern means you're going to be doing law of cosine. You have side, angle, side. And remember when you named these and used these congruency theorems, and there's also hypotenuse leg for a right triangle. When you use these congruency theorems in geometry, you could go around the triangle and skip a part, but not two or multiple parts. Like this is not side, skip, 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 side, angle. Besides side, side, angle, if you spell it backwards, is a bad word, right? No, this is side, angle, side. So a side, angle, side pattern means you're going to be using law of cosine. And it also means that because these are congruency theorems, given information like this means that you can only construct one triangle. Over here, before I highlighted the stuff in yellow, we had angle, side, angle. That was a congruency theorem in geometry, which means, one, there's a answer that is possible, a triangle that you can construct with these three pieces. It also means that you're going to be using the law of sine. And then finally here we have what? We have angle, angle. We can skip an unmarked side, side, angle, angle, side. We cannot do what? Angle, skip, side, skip, angle. You can't skip two blank parts. That's illegal. That's angle, side. Congruency theorem, one triangle possible, law of sine. The last video in this three-part series, thank you for sticking through all this introductory material. Of course, the point is that it helps. Is this guy right here. This one's a little bit nasty, and this is actually, this particular version is the main reason why I want to revisit these videos, besides the better lighting and sound quality, because, well, this particular old lesson has some minor errors in it, and YouTube took away the annotation corrections, and so now it just looks like I made a bunch of mistakes and left them there. What is the information here? The information here is angle, skip, side, skip, side. This is the side angle. Or if you spell it backwards, don't say it out loud. It's a three-letter word. It's not a four-letter word, but it's a three-letter word that we don't really want to say, especially not on camera to potentially kids or my own students. So this is not a congruency theorem, which means that this information of given a side of 37, 42, and an angle of 112 degrees opens the door for there to be one triangle. I mean, I drew one, but maybe there's zero triangles. This is not a congruency theorem in geometry, so these three pieces don't even necessarily have to make a triangle. Or there might be two. So we'll be reviewing that and visiting that concept in a couple of lessons, but for right now, let's get on to the law of sine. So we're going to get into part A here. This time actually labeled with some vertice names, and grab a piece of chalk. Let's get started. Okay, for solving triangle A, we don't need a whole lot of work for the measure of angle C. That's going to be 180 minus 48 plus 37. Well, we're looking at 48, 78, and what? 85. 85 take away from 180 is going to be 95 degrees. Okay. Let's, and we'll put this in green to make it stand out. Hopefully it is on camera as well. Let's find the measurement of side B. Okay, so here's all you have to do. Take the given information, the measure of that side over the sine of 48 degrees. Make sure your calculator's in the correct mode. So we have 100 over the sine of 48 degrees is then equal to B over the sine of B. B is 37 degrees. B is being divided basically by a constant, whatever the sine of 37 degrees is. So we multiply both sides by that constant and get 100 times the sine of 37 degrees over the sine of 48 degrees is equal to B. And grabbing a calculator, that comes out to be 81 units, 81.0 units. Okay, and then to continue the process into solving for side C, if I typed something into my calculator incorrectly, typed in 36 degrees or 90 because I missed a 1 or something, or maybe 200 because it's next to the 1. If I use that information that I found to then find another piece of the triangle, I'm going to take any potential error, hit the wrong button on the calculator, and carry it through to another part. That's not a good idea. If you can ever avoid using information that you found yourself, you don't then carry that error through to another part. So we're going to once again use the given information of 100 and the 48 degrees and say that we have 100 over the sine of 48 degrees. And of course, we can't always avoid using information we found on our own, but and we have that 95 degrees in the side C, so we're going to have C over the sine of 95 degrees. Again, we have just our unknown divided by a constant, so we're going to undo that division by multiplication. Multiply that sine of 95 degrees over to the left, and we have 100 over the sine. 100 times the sine of 95 degrees over the sine of 48 degrees. And that's still equal to C. And C is equal to, right off the top of my head, well, it's 134.1 units. And that is, well, the end of this particular problem. Let's get on to part B. So for part B, now recognizing that this is an isosceles triangle means that since these base angles are equal, then the measurements of A and B are also equal. So this is going to go quite quickly because I don't need to go through 2 steps of law of sine, just 1. Because, again, A and B are the same measurement. So start off with that known side. And we weren't given angle C, but it was very easy to find, our 50 degrees. So we're looking at 3 over the sine of 50 is equal to A over the sine of 65 degrees. And then we're going to, again, our unknown is divided by a constant, multiply both sides by that constant, multiply both sides by the sine of 65 degrees, and we have 3 times the sine of 65 degrees over the sine of 50 degrees is equal to A, and A is going to come out to be, dun-da-da-da, right off the top of my head, not really, my calculator, it came out to be 3.549 units. And since this is an isosceles triangle, the sides opposite the equal base angles are themselves going to be equal. Now, to finish this up, these were both very, very similar. The problem is if you have to find an angle using the law of sine, you have 2 issues. If you're finding an angle with the law of sine, that means the original problem was in that side-side angle pattern, and that's not a congruency theorem in geometry, opening the door for there to be 1, 0, or 2 triangles. We'll be looking at that soon. And secondly, let's not forget that when you do the inverse sine of not an angle, but the ratios out of a right triangle of y over r, I'm saying this in terms of if you're in trig and you're working with a lot of angles in standard position, where instead of saying sine of theta is opposite over hypotenuse, we say instead, because it's more convenient, more appropriate, y, vertical movement over r, the distance your point is away from the, or the vertex of your sort of right triangle is away from the origin. Well, that's going to give you some kind of angle measure. And your inverse sine, working as an inverse sine function, means that you're not going to be able to get an infinite number of possible answers. Working with inverse sine as an inverse sine function means that you're only going to be given one measurement, and that is that this value is going to be giving you angle measures that are greater than or equal to negative 90 degrees and less than or equal to 90 degrees, or negative pi over 2 to positive pi over 2. So you can only find acute angles using law of sine. So if you were to try and find this angle that's opposite the largest side of this triangle, which we can see here was an obtuse angle, if you were to use law of sine to find that missing angle of C, the calculator would not be able to tell you that it was 95 degrees. It would actually tell you that it's 85 degrees because the sine function is an even function and symmetric to the y-axis. So the sine of 95 degrees is the same as the sine of 85 degrees, or both 5 degrees off the y-axis, or they both have a reference angle of what? 85 degrees? Yeah. Yes. Anyway, we'll get to that as we cover our next section, our next video, which is solving oblique triangles using the law of cosine. I'm Mr. Tarrou. Bam! Go do your homework.